Hello! In this video, we present the synthesis of diazepam by flow chemistry according to the retrosynthesis shown in the previous video. The synthesis is notable for using flow chemistry, starting from substituted benzophenone to construct the diazepam. This intermediate is obtained from orthonitratoluene and phenylboronic acid. Preparation of the substituted benzophenone. The oxidation of orthonitratoluene 1 is carried out in a liquid biphase using phase transfer agents and sodium hypochlorite as oxidizing agent with catalytic amounts of ruthenium trichloride, which in a basic medium forms ruthenium tetraoxide, which is the oxidant of the methyl group to obtain carboxylic acid 2. The decarboxylative cyanation of 2 is carried out using oxygen and cuprous iodide in the presence of melanonitrile. The oxygen oxidizes copper 1 to copper 2, which causes decarboxylation to generate phenyl copper, which is added to one of the natrile groups of melanonatril and forms the amine 4 as an intermediate, which in a basic medium eliminates acetonitrile to produce intermediate 5. The chemoselective reduction of the nitro group in 5 is carried out using sodium iodide and triphenylphosphine to form an acceptor-donor complex with the nitro group. The reduction with phenylsilane produces aniline 6 almost quantitatively. The regioselective aromatic chlorination at the para position to the amino group in 6 is performed with N-chlorosuccinime with visible light and a carbazole derivative as a promoter to obtain 7. The addition to the cyano group in 7 by a phenyl group is carried out by a reaction catalyzed by palladium 2 complexes using phenylboronic acid 8. The initially formed amine is hydrolyzed under the reaction conditions to produce benzophenone 9. Under flow chemistry conditions, the monomethylation of aniline 9 uses methyl carbonate, considered a green chemistry methylating agent, and DBU as a base. Under the reaction conditions, first, carbamate 11 is formed, which is then methylated in the presence of DBU, and finally decomposes to generate methylated aniline 12. Diazepam by flow chemistry. Through flow chemistry, benzophenone 12 is reacted with bromoacetyl chloride 13 in the presence of propylene oxide 14. In microfluidic microreactors, the amidation reaction first generates the amide 16 as an intermediate. It is worth noting that propylene oxide reacts with the hydrochloric acid generated at this stage, thus preventing the protonation of the amine 12 and stopping the reaction. The reaction mixture is transferred to a second microreactor where ammonium hydroxide is added, which generates ammonia and through nucleophilic substitution produces the aminomide 17, which by intramolecular addition of the amino group to the keto group produces diazepam with 96% yield. In summary, here are the raw materials and their structural contribution. Thank you for your attention.